Good afternoon, everyone, and welcome to the Brunel Robotics and AI Expo 2020. When I was first invited to speak at this expo, I was just looking back and recollecting for how long I've been associated or have been interacting with Brunel Robotics and Engineering Society. It goes for past few years, and I've seen them grow from just inviting speakers to do some lectures to their students and the society members. And now look at this, they are organizing an expo and have got amazing speaker lineup and exhibitors. And I'm really pleased about how they have progressed in these years. Hope representing Shadow, we are not letting them down and trying to come up with new and exciting things to share every year that we are being invited. So thanks again for inviting me. And to introduce myself, I'm Radhika, working at Shadow Robot Company. So let's get on with presentation for today. Okay, so the today's topic is to talk about why is tactile sensing for touch important in robotics. So I'll take you through a brief background about what we do at Shadow Robot and what intrigued us to get into touch feedback and how can that be helpful in robotics. So moving on, we are a small robotics company. We started as a robotics hobbies group back in 1990s and formed into a company in 1997. Apparently, the first robot that was built was with wood, and the first task that it did was open a can of beer and pour it into a glass, which is exciting. Right now, we are about 43 to 45 full-time employees. Most of them are robotics engineers who are working either with the hardware, software, or testing and other aspects of robotics. We have got good distribution, global distribution of sales and a reseller network. And we have got a global network of collaborators and partners. So here's a glimpse of clients. So as you can notice here, we work with global corporates and big companies. We have supplied our hands to NASA. We have supplied our hands to ESA in the past. And we work with global universities. You can see Carnegie Mellon here, University College of London. And we also work with startup companies. For example, on the bottom left, you can see SynTouch. We have been working with their tactile fingertip sensors and integrating them into the Shadow hands. So we are predominantly a research and development company, and our products have been research products for a long time, for the majority part of our existence since 1997. Most of our clients have been either academics with the title professor or research and development organizations. We supply our hands to these people and they do exciting research. And sometimes we can't believe ourselves that our technology is capable of doing those amazing things. So apart from supplying our technology to research and organizations, research and development organizations, we ourselves do quite a lot of internal R&D. As you can notice here, we are involved in many collaborative R&D projects, the public funded projects like Innovate UK, and also at the European level with Horizon 2020, if you're aware of that. So currently, there is one ongoing Innovate UK project. We are working with some of the research organizations and industry partners, where one of the partners is developing tactile skin on a hand, so which can be helpful for handling soft objects like fruit. We are not getting into the area of uh, picking the fruit or into the agriculture side of things, but we are more focusing on the packaging and processing side of things in the food industry. So with the Horizon 2020 projects, these are the European initiatives. This gives us an opportunity to work with many European organizations, be it universities or R&D organizations, or even the industry partners. So currently there are 4 ongoing Horizon 2020 projects. I think 2 of them are around flexible object handling, like how do we handle textiles? How do we handle composite materials uh, for laying them up on structures, like when you're building coaches or trucks? So having composite materials laid on top of them apparently is a ergonomically challenging task and requires um, more than few human workers to do the job precisely and getting the things right. So these are the exciting use cases that we are working on in our European projects, and some of which I can share with you later in the presentation as well. So here comes flagship product, which is popularly known as dexterous hand in the research and the industry communities. So this has been developed as a very first prototype in the early or late 1990s, and we have been improving on that since then. Initially, it was a pneumatic version of it. Now we have different version where you can see all the tendons. So if you notice the wires that are running through, these are the tendons which control the robot hand, and a hand can match the human manipulation capability and the dexterous capability as close as possible. And as far as we are aware, there is nothing else that is commercially available which can match the dexterous ability of our robot hand. So at the bottom, you see our hands fiddling away with the cube. This is a research outcome of our work with OpenAI, which is a sister company of Google. So OpenAI approached us, I think in 2017. So they said they are developing many deep learning and reinforcement learning algorithms in order to test complex manipulation abilities. So they couldn't find a hardware that is capable enough to survive their complex manipulation algorithms. So when they approached us and showed us their algorithms, even we were not fully sure how that's going to work on our hardware, or how our hardware would survive such a complex learning process. But we thought, okay, let's get on with it and see how it goes. They initially tested their reinforcement learning algorithms in the simulation settings. I think Gazebo or Mujoko, one of those simulation platforms. And that worked really well. And they came back to us saying they would want to try it on the real hardware. And as you can see here, these are the recordings where the hand learned by itself using their machine learning algorithms how to fiddle with the cube. So yeah, quite pleased with this research. So coming back to our today's topic of touch and how touch can be important in robotics. Most of us who are familiar with the robotics world usually are occupied with the sense of vision. So most of the research happens in how to make the vision sensing better, how to equip robots with cameras, or how can we make them see like a human would see. But apart from vision, there are various other senses that humans use in order to figure out how to do a task, or how to navigate their way around in a setting. So that's what brought us into exploring what touch is, because human hands are one of the most amazing body parts, and they use the sense of touch quite a lot. And when I first started at Shadow, I realized that even the fingernail plays plays a key role in figuring out what is the kind of object that we are trying to hold or grasp. And that gives us apparently lots of force feedback on how, what kind of grasping we need to use in order to hold an object. Looking at this image, it takes me back to one of the little incidents that happened when my son was very little. I think he was about 6 months old, slowly starting to crawl, learn how to crawl. So I was doing some chores in the kitchen, and there was a small step from the living room into the kitchen. I was keeping an eye on my son. He was playing, crawling in the living room, and until then, he never ventured to uh, go crawl over a step. So I was pretty much confident that he's safe in the living room, keeping an eye on him, carrying on my job. But in the matter of moments, he learned how to crawl onto a step, came into the kitchen, and I left a hot pan, a pressure cooker, on the kitchen floor because I didn't have enough space on the platform. He he went, like kids would always look for danger. He went and touched the pan, started crying, obviously. But of course, that was like we had a big drama in the house as to how come I didn't keep an eye on him and everything. But eventually, we learned that ever since, whenever he came across a metal object, he would first go do this, touch, and then see whether that is safe enough for him, not too hot to hold, and then only venture holding it and playing around with it. So that's how humans learn from the sense of touch. So this is just an example of at how early an age that humans would start learning and using the sense of touch. So moving on, if I don't know whether people have come across haptics. Most of you working in the world of robotics would usually have heard about haptics and how they are used in various robotic applications. So haptics is the sense of touch, or the technical term that people use for sense of touch. But there are two modalities in haptics. One is kinesthetic and other one is tactile. tactile, kinesthetic mainly gives you an idea about what is the shape of an object or the size of an object and probably the weight of an object. So this is the feedback about shape, size, volume, and weight of the object. When it comes to the tactile feedback, it's more about the surface texture, hardness, or the temperature, and those kind of things. So the tactile feedback is mainly conveyed through the fingertips of human hands. So that is why we are focusing more on the tactile feedback side of things at Shadow. Eventually, we'll also move on to the other feedback of kinesthetic. So here you can notice on the right-hand side, a gripper, a simple gripper, robotic gripper, which only works based on the vision, was unable to figure out how much force or pressure to apply on picking up a can. And eventually the can has been deformed. So how can we rectify this? How can we use the sense of touch to give us feedback of how to grasp an object? So here, if you have noticed how robotics are being used and how the sense of touch is important in various robotic applications, um, lot of there are lots of publications and lots of research going around surgical robotics and how we can equip clinicians and surgeons to be able to operate or do the surgical procedures by using laparoscopy or using smaller incisions so that the recovery time for the patient is quicker. So for these, there are very highly developed and exciting or amazing technologies or robots that are out there. Da Vinci robot is one of them. Um, the issue with these robots is the surgeon is already unable to see what is out there. So there are some cameras. So there is a sensory overload for the surgeon. If they're cutting open and doing it like a normal surgery, they would have the sense of touch. They would palpate, so tap on the tissue, figure out which is the bad tissue and where they need to operate, which can be quite easy or a good feedback for the surgeon. But with that missing in the laparoscopic side of things, they require huge amounts of training and preparation time, and the procedure in itself will be quite slow and expensive. Or everything put together will make the whole process expensive. So adding the sense of touch, therefore, helps to make the entire process quite intuitive and also feels quite natural for people to adapt because they use more than one sense. It's not just vision. They use the audio cues, they use the sensory cues, and they also use the smell in order to carry out the task. So what have we done with the sense of touch? How did we bring the sense of touch into our shadow robot hands? In 2018 or beginning of 2018, we were approached by a Japanese air fleet manufacturing company called All Nippon Airways, or for short, ANA Holdings. They came to us with their dream idea of telepresence becoming a reality. So their dream was to having a person sitting in one location, being able to experience everything that is going around in a place they really want to be in. So that is the idea of telepresence they came to us with. And when the idea was first proposed to us, we thought, okay, we have one piece in the puzzle, that is the hand, which people often use to feel and experience and touch and find out what's happening around them. So we need the other pieces in order to put together the whole experience of telepresence. So we joined forces with two other companies called Haptex and SynTouch. Haptex make or design and develop sensorized haptic gloves that can transmit the sensation of touch. And SynTouch designs tactile sensors which can be embedded onto the fingertips of shadow hand. So here you go. You see some of the images here where shadow hand being controlled by a person wearing the haptics gloves, and the teal tactile fingertips that you see on shadow hand are the SynTouch sensors called biotags. So we even solved the Hello World program, which is the very first one that we do in the programming world. So if at all any of you are having issues sitting in front of the laptop the whole day and have issues with your neck and your back, get in touch with us, or feel free to buy one of our robots to massage your neck and your back. So moving on, probably I'll play this video, which so like you have watched in this video, this was in beginning of 2020 in CES Las Vegas event, where the person who was experimenting or playing around with our system was a journalist who came to visit the expo, and he dropped by to our booth. So there was very limited training time, and the journalist could literally use the system and do the tasks that were available there, like stacking cups or fiddling with the Rubik's Cube and all. So how does it work? So as you can see, the person wears the sensorized haptic gloves, and the haptic gloves have got some sensorized pressure bubbles in here. And I think each fingertip has got around 20 to 25 such pressure sensors, which as you noticed in the video that was played earlier, they are like bubbles which inflate and deflate depending on where the touch is happening. And this feedback is transmitted to the human. So the robot hand actually does the task, and the feedback is transmitted to the human. And obviously the human can control the robot to do the job as well. So that's how it works. And once we developed the system with Anna in the Avatar X Prize program, where we were the recommended hardware suppliers for people who were taking part in the competition, That was noticed by Amazon, and we were invited to take part in the Amazon Remarch event, which is an internal Amazon event or a showcase event where so many of their clients are invited. And that's when Jeff Bezos tried playing around with our system and had fun, obviously, as you can see it here. So moving on. So we have now created a telepresence technology which can take people across the globe, make them experience the hear, see, and feel what's happening in a different part of the world, even cross continents. So how are we going to use that or put that into commercial applications? So as you can see here, there are teleporting skills, where an expert technician is needed, and also dangerous or inaccessible environments. For example, in nuclear decommissioning, where human workers have to go in fully clad in PPE, and also in pharmaceuticals, where hazardous chemicals are used. So these are some of the applications and the market areas that we are exploring. And one recent development during the pandemic is we were approached by a big giant in US engineering client who are having issues with remote maintenance and the skilled technician being able to travel to the problem location in time. So what we have done is we have put together teleoperation system and shipped it to the client. They are testing it in their mock-up environment and are finding good results. So the person can still sit in the comfort of their home or in a control room, which is closer to their location where they live. And as the problem is reported, all that they have to do is wear their gloves, figure out where the problem is, do the fix, and that's it. They can either go back to what they were doing before, or if it is in the middle of the night, they can go back to sleep. So that is where we are. And I'll stop talking for now. And here are our details to contact. We are scaling up as a company, and we are recruiting crazily, looking for so many skills that we need in order to scale up the company. So please feel free to get in touch. And thank you for inviting me today.
Welcome back, and thank you very much for that presentation. We will now be going into some questions, some of which are from us and some of which are from the chat. So if you do have any more questions, keep them coming and I'll see if I can catch them and have enough time to ask them. So my first question was, as one of the longest established robotics companies in the UK, how have you noticed the industry change and evolve throughout the years as a company?
I have been with Shadow probably the last 3 years, but I can answer this on behalf of various conversations we have internally at Shadow. Essentially, we started off as a research product development company, and we stayed as a research product development company. But the transition we are seeing in the last years is there is quite a lot of traction in taking the robotics into commercial applications in the last few years. Before that, it was more lab-based research. There are some cool things coming out of research labs and from hobbies groups, but the last five to 7 years, I would say, the entire robotics world has changed, and it's like thriving right now.
Brilliant. Yeah, this is very, very exciting industry, which we're all very proud and I'm sure excited to be a part of. And on that sort of similar note, how do you feel that the extra years of research and development have helped you become the leaders in such a field?
I would say it's both positive and negative. On the positive note, we always get to work in that zone where it's always exciting to pick up a new challenge. But on the downside, we have got limited experience in launching ourselves into the actual commercial applications, which we are focusing a lot in the last 4 years, I think. So yeah, there is a bit of both, understanding what are the nuances in the lower technology readiness levels before commercialization. And now we are trying to understand the ones in the higher technology readiness levels ready for commercialization.
Oh, fantastic. Very, very interesting insight. My next question was more personal curiosity. How does the work that you do at the Shadow Robotics company, how is that applicable to other fields, such as, for example, the haptics in virtual reality, or maybe surgical robotics and things like that are sort of outside of the focus but still apply in the same way?
Mm-hmm. Probably I look at this question from a perspective outside Shadow Robot. So if you look at the technologies like haptics or vision solutions, we are one of the technology providers from doing the grasping and manipulation side of things. But you can't do anything exciting just taking a robot hand. So it is only one piece in the entire solution or the puzzle. So combining our technology with other pieces like haptics, be it the development of haptics from the gaming community or be it from the surgical intervention community, um, tying that up with our piece of technology and tying up the vision solutions and the development of AI that is expanding the scope of vision would let us make a holistic solution to solve a commercial challenge. So none of us can work on our own, I would say, but all of us put together would solve a bigger challenge. So that's how I would look at it as.
What a lovely answer. And I feel like what personally I'm most excited about in robotics is people's different work coming together to make one beautiful thing. Which actually you've touched upon it. So my next question would be, how can you go more into depth about how you use artificial intelligence and how that integrates with the work that you're doing at Shadow Robotics Company?
Mm-hmm. So as such, we don't claim ourselves doing anything which particularly fits into the AI side of things. But if you look at the grasping library that we have built from ages, that would essentially mean machine learning. So having a library, if you are presented with an unknown object, coming up with a grasp to pick up that object is kind of machine learning, but we have never claimed doing that. Coming back to what we do in terms of AI is we do more in terms of hardware and the software that is relevant to that, but we collaborate with other AI experts in the market. For example, you would have watched the video or the GIF of our hand fiddling a robot cube. So this is the work we have done with OpenAI. So we collaborate with the AI experts out there to embed that into our. And one of the other projects we have done is with a European academic where they were developing neuro rehabilitation platforms. So they have integrated our simulation model into their AI platform where neuro researchers could work with complex AI algorithms using our hand.
It's fascinating. On the subject of the fascinating work you're doing, in that really fascinating and quite funny video with John Richardson doing the it's from all the way to LA, and you were talking about they said about zero latency. Do you know much about how you managed to achieve that?
Yeah, we are being approached by quite a lot of 5G network providers claiming that the latency issues wouldn't come up. But from our own experience, I'm not demeaning the 5G work or the developments that are happening in that area, but any good 4G network with a good connectivity always worked fine for us. But what we try to prioritize is to send the teleoperation data, give it more priority than the video data. Sometimes the video data might have some lag. So in those cases, when the network is patchy, the person would get the sensation of touch first and then see the video being streamed. But even in those cases, there were 120 millisecond delay that we experienced, nothing more than that. So latency is not as big a thing as everyone would expect, at least from our experience on Earth. It might be different when we look into the space applications. Yeah.
Oh, fantastic, very interesting. And just one last quick question before we head off for an intermission. Does the hands have a heat element for the haptics, or is that how is that done?
Mm-hmm. So at the moment, we do have temperature sensors in our hand, but in all the commercial applications that we have worked till date, we have only been working in the tasks that a human would do. So any kind of normal temperature ranges from probably 0 to 40 is where the temperature element was tested. We are being approached by some of them in other wider temperature ranges, but we haven't yet tested that.
All right, thank you very much. Well, that was fascinating. Thank you so much for coming and presenting.